I saw this problem on Mike's math page at WordPress. Mike and his son were working through this problem. They did it in about 4.5 minutes in live time, something I would not be able to do. And I just love the problem. I liked it because it shows how well calculus plays with other maths. And this is also a problem I probably wouldn't have done by myself because it has this word normal line in it. And, I don't know what a normal line is. So if I'd seen this problem on my own, I probably would have never done it. Because I figure if I don't know what a normal line is, I probably don't know anything else. Well, it turns out the only thing I didn't know was a normal line. And it's not such a hard concept. So this is asking, where does the normal line to a certain parabola at a certain place intersect the parabola a second time? Well, turns out a normal line is basically perpendicular to something else. And in this case, the something else is a point on a curve. So let's say the point is there. I can find out what the slope of that line is. And then I go perpendicular to it because that's what I'm trying to find. And that's my normal line, this perpendicular line. It's 90 degrees because that's what perpendicular is. It's been rotated. And so I'm trying to find the slope there. So that's what the normal line is. So I need to start off actually right away trying to remember, if you know the slope of this, how do you figure out the slope of that? Remember, it has something to do with negative. Okay, so what I'm going to do is think about a triangle, and the slope that is described by the legs of this triangle would be 3. In the denominator, that's the run, and the rise would be positive 5 going up. These are both positive. If I take this and I rotate it 90 degrees, just rotate it 90 degrees. Now my rise is negative 3 and my run is 5. Okay, so this reminds me that if I know this slope, this is the negative reciprocal. The slope of this is the negative reciprocal. Done. Okay. Next thing I want to do is I want to draw what this parabola looks like, and that helps me visualize things right from the start. So the x squared is the highest power. That's going to determine the shape of this graph. So it's going to be like something like this. And I know one of the roots already because the y is 0. So here's a root. And I also would like to know what this root is. It'll help me situate it. So to do that, I factor the equation, and I find the zeros where this is satisfied. Well, I already know that 1 satisfies this equation, so now I know that the other thing that will be a root is x equals 0. So this point is 0, 0, and this point is 1, 0. I can now draw my axes. And what I'm looking for is to find, the question is asking me to do, is I need to find the slope of this line and then find where the normal line intersects the parabola. So I need this one right here. So good. That's what I need to do. I've done some geometry, some curve sketching, and now I need to do some calculus. And this is probably the easiest part because this is a pretty easy calculus problem. We know that the derivative of x is 1, and the derivative of x squared is 2x. And we want to find the slope where x equals 1, So that's 1 minus 2 to the 1 minus 2, so it's negative 1. So the slope of this line right here is negative 1. That looks right. Okay? So now that means negative reciprocal of negative 1 is 1, so my normal line slope equals 1. Great. Next, I need to find the equation of this line. I know a lot about it already. I know one of the points on it, and I know what the slope is. So my equation of the line formula is going to work just fine here. M equals 1. I'm going to have x equals 1, y equals 0. So I know that, and I know a lot of stuff. I just need to solve for b. Plus b. So 0 equals 1 plus b, and b then equals negative 1. So my equation for the line, I only need b and m for the equation of my line. Y equals 1x plus negative b, negative 1, which is the same as x minus 1. So that's the equation of this line, x minus 1. Not done yet. I've got to now set these two equal to each other, and that'll tell me what this point is. System of equations. Okay, so x minus x squared equals x minus 1. I subtract x from both sides, end up with x squared equals negative 1. X equals plus or minus 1. Well, we already know that x equals 1, so what we're probably looking for is the other, what we are looking for is not the positive one, we're looking for the negative one. So we've got a negative 1 here. And that sort of looks right with my drawing. Now I put negative 1 in this or both equations. I'm going to put it in this one. That looks really easy. So x minus 1 at x equals negative 1 equals, that would be negative 1 minus 1 equals negative 2. Yay, so that's the solution that the Lawlers got and what I got. But for me, this wasn't about finding the solution. This was about talking about all the different pieces. First I had to do a web search, and then I had to think about the equation of parallel lines, which is coordinate geometry. I did a little bit of curve sketching, which is pre-calc. I had to do some calculus to find the derivative. I used my equation of the line formula here, and a system of linear equations. So this is just showing how calculus plays so well with others. Now, to try to do this without calculus is kind of like playing soccer without a goalie. But you don't need just the goalie, you need the whole team. And I just think it's a great problem, which I wouldn't have done without the Lawlers, so thanks for the inspiration. This is a lot of fun, and I think it's a great problem for people who don't know calculus even to do. You just need to be given this part, and you see how everything can work together.